Hi, and welcome to exercise 1D, still on the simplification of exponential expressions. Before we begin, it would be nice for us to remind ourselves of the laws. You know that any number raised to power a multiplied by the same number raised to another power b is equal to that number raised to power a plus b. You know that a number raised to power a divided by that same number raised to power b equals that same number raised to power a minus b. We know that any number raised to power 0 equals 1. We know that a number raised to power negative a equals 1 over that number raised to power a. We know that a number raised to power 1 over a is the same as the eighth root of that number. And we know that a number raised to power a divided by b is the same as the bth root of that number raised to power a. And of course, we know that a number raised to power a all raised to power b is equal to that number raised to power a multiplied by b. So with that, we head into the exercises. Number 1. 2a multiplied by 3a squared. And as usual, we deal with the coefficients 2 and 3. So we have 2 multiplied by 3 multiplied by a. Here a is raised to power 1. And because of the multiplication, we add 2 to it. So this gives us 6a cubed. Number 3. 2a squared multiplied by 3a. We know that in this case, everything inside the bracket is squared. So we have 2 squared a squared multiplied by 3a. And this gives us 2 squared is 2 times 2. That is 4a squared multiplied by 3a. Now here we can go on to multiply the coefficients 4 and 3. And that gives us 4 times 3 times a. Here a is raised to power 2, and because of the multiplication and a being raised to power 1 here, we add. This gives us 12a cubed. Number 5. 27 raised to power 1 over 3. Now, according to this law, we have that this is equal to the cube root of 27. And we know that the only thing that we can multiply by itself 3 times to give us 27 is 3. Because we know that 3 times 3 times 3 is 27. Therefore, the cube root of 27 is 3. Number 7. Cube root of 2 raised to power 6. This has been expressed in this form. So what we do to simplify is to bring it to this form. Here we have cube root of 2 raised to power 6. Cube root of 2 raised to power 6. So here x is 2. A is 6. A is 6. And B is 3. And we know that 6 divided by 3 is 2. So we have 2 raised to power 2, which is 4. Number 9. 2 raised to power minus 2. According to this law, we have that this can be expressed as 1 over 2 raised to power 2. And this is 1 over 4. Number 11. 9 raised to power half. According to this law, we have that this is the square root of 9. And we know that the square root of 9 is 3, because 3 times 3 is 9. Number 13. 25a squared raised to power half. Now we know that 25 can be expressed as 5 squared. We also have a squared, all raised to power half. Now, since the two items inside the bracket are raised to the same power, we can bring it out as 5a squared. And then we have half, this half. This is not part of this question. And according to the last law, where we have that x raised to power a raised to power b is equal to x raised to power a multiplied by b, we have that this is 5a raised to power 2 multiplied by half. And we know that 2 multiplied by half is 1. So this is equal to 5a. Number 15. 2a raised to power minus 1. According to this law, we have that this is 1 divided by 2a. Number 17. 2 raised to power minus 2 multiplied by 2 raised to power 3. We have 2, we have minus 2. Because of the multiplication, we have plus according to the very first law, and we have 3. So we have 2. Minus 2 plus 3 is the same as 3 minus 2, and that gives us 1. Number 19. 10 raised to power minus 2. According to the same law, this is equal to 1 over 10 squared. And we know that 10 squared is 10 times 10. That is 100. Number 21. 3a raised to power minus 2. This can be written as 3 multiplied by a raised to power minus 2. And we know that this is 3 multiplied by 1 over a squared, according to this law. And this can be written as 3 divided by a squared. Number 23. 'Square root of 3 raised to power 4. Once more, we have this law. It has been expressed as this, And we know that here 4 is A, and the square root, that is 2, is B. So we have that this is equal to 3 raised to power 4 over 2. This is 3 raised to power 4 divided by 2 is 2. This is equal to 9. Number 25. 1 over 9 raised to power minus 1. When we have a fraction and a negative index, to remove the negative sign, we flip the fraction upside down. That is, the denominator becomes the numerator and the numerator becomes the denominator to remove the negative sign. So here we have 9 over 1 raised to power 1. And we know that this is equal to 9. Number 27. 3 raised to power half multiplied by 3 raised to power 3 over 2. Here we have 3. Because of the multiplication, as usual, we add the indices. Half plus 3 over 2. When adding fractions or subtracting fractions, we usually find the LCM. But in this case, the two fractions have the same denominator, that is 2. So we can simply add the numerator immediately. So we have 3 raised to power 3 plus 1 is 4 over 2. And we know that 4 over 2 is 2. So this is equal to 9. Number 29. 3 raised to power half multiplied by 3 raised to power minus 3 over 2. This is almost the same thing as the previous example, just that instead of 3 over 2 here, we have minus 3 over 2. So we go on to do the same thing. 3, because of the multiplication, we add the 2. Half plus minus 3 over 2. And we know that plus minus is minus. So we have half minus 3 over 2. As before, the fractions have the same denominator, so we go on to subtract the numerator. So we have 1 minus 3 is minus 2 divided by 2. And this gives us 3 raised to power. This will go into this to give us minus 1. And as usual, according to this law, we know that this is simply 1 over 3 raised to power 1. And that is 1 over 3. Number 31. 2a raised to power minus 1 multiplied by 3a squared. As usual, we deal with the coefficients 2 and 3. So we have 2 multiplied by 3 is 6. A raised to power minus 1. Because of the multiplication, we add the indices plus 2. And this gives us 6a raised to power 1. Because minus 1 plus 2 is 1. And that's 6a. Number 33. 2a raised to power minus 1 multiplied by 3a squared. Here we have 2a raised to power minus 1 times, to open the bracket as usual, we raise everything inside the bracket to power 2. So we have 3 squared e squared. So this is 2 a raised to power minus 1 multiplied by 9a squared. And as usual, we deal with the coefficients. 2 times 9 is 18. A raised to power minus 1. Because of the multiplication, we add the indices. Plus 2. So this gives us 18a minus 1 plus 2, as usual, is 1. So that is 18a. Number 35. 2 raised to power half multiplied by 2 raised to power 3 over 2. And as in the previous exercise, we have 2 raised to power half plus, because of the multiplication, we add 3 over 2. Also, the two fractions have the same denominator, so we go on to add the numerators immediately. So we have 2, 3, 1 plus 3 is 4, divided by 2. This is 2, 4 divided by 2 is 2. That's 4. Number 37. 125 raised to power minus 2 over 3. According to this law, we have that this can be stated as 1 over 125 raised to power 2 over 3. And the denominator, according to this law, can be stated as 1 over cube root of 125 squared. According to this law, cube root, this can be stated as cube root of 125 squared, according to this law. So here we have 1 divided by, we know that the cube root of 125 is 5, because we know that 5 times 5 times 5 is 125. So the only thing that we can multiply by itself 3 times, 1, 2, 3 times, to give us 125 is 5. So the cube root of 125 is 5. So this is 5 squared. 1 divided by 5 squared. And this is simply 1 over 25, because 5 squared is 5 times 5, which is 1 over 25. Number 39. 16 raised to power minus 3 over 4. As in the previous example or exercise, we have that this can be stated as 1 over 16 raised to power 3 over 4. That is according to this law. Negative, according to this law. And according to this law, this can be stated as 1, the denominator can be stated as the 4th root of 16 raised to power 3, where 4 is equal to B, 3 is equal to A, and 16 is X. So here we have that the question here is, what do we multiply by itself 4 times to give us 16? What must we multiply by itself 4 times to give us 16? And we know that it is 2, because 2 times 2 times 2 times 2, 4 times is 16. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So the 4th root of 16 is 2. So we have that this is 1 over 2 cube. And we know that 2 cube is simply 2 times 2 times 2. And that is 2 times 2, 4 times 2, 8. So this is simply 1 over 8. Number 41. 2a multiplied by 3a raised to power minus 2. And as usual, we deal with the coefficients 2 and 3. 2 times 3 is 6. You write a. Here, a is raised to power 1. And because of the multiplication, we add the indices of a plus minus 2. This is 6a raised to power 1 plus minus is minus. This is equal to 6a raised to power minus 1, because 1 minus 2 is minus 1. And according to this law, a can be written as or 6 over a. Number 43. 4 raised to power minus 3 over 2 minus 3 over 2. Once more, according to this law, we have that this is 1 over 4 raised to power 3 over 2. And then according to this law, where a is equal to 3 and b is equal to 2 and x is equal to 4, we have that the denominator is 1 over 4 raised to power 3. And this gives us, the question is, what is the square root of 4? And we know that that is 2 multiplied by 2, because the only thing that we can multiply by itself twice to give us 4 is this. So we have that this is 1 over 2 raised to power 3. And that's 1 over 2 times 2, 4 times 2, 8. 1 over 8. Number 45. 1 over 3 raised to power minus 2. Now, because 1 raised to power anything remains 1, you can write this as 1 over 3 raised to power minus 2. And we remember what we said about fractions and negative indices. To remove the negative sign, we must flip the fraction upside down, such that the denominator becomes the numerator and the numerator becomes the denominator. So we have 3 over 1 raised to power 2. And this is simply 3 raised to power 2, which is 9. Number 47. Cube root of 4 raised to power 1.5. Now, when simplifying exponentials, whenever we have a decimal, it is best to express the decimal as a fraction. It makes life a lot easier. And we know that 1.5 as fraction is 15 divided by 10. 5 into this 3, 5 into this 2. So this can be written as cube root of 4 raised to power 3 over 2. According to this law, we can write this as 4 raised to power 3 over 2, where 3 over 2 is A and 3 is B, divided by 3. Because from here, we can see that 1.5 is A, and we have expressed 1.5 as 3 over 2. So that is A, and 3 is B, and 4 is X. So writing it in this form, we have X as 4, we have A as 3 over 2, divided by B, divided by 3. And of course, we know that when you have divided by and you want to change with multiplication, what you now do is 1 over 3. From here, 3 will go into 3 to give us 1. And we have that this is equal to 4 raised to power half. And that is going back square root of 4. And this is 2. Number 49. 64 raised to power minus 5 over 6. And once more, to remove the negative sign, we rewrite it in this form, 5 over 6. Now the denominator, according to this rule, can be rewritten as 1 over 6th root of 64 raised to power 5, where from here 5 is equal to A, 6 is equal to B. So in this form, X is equal to 64. So 6th root of 64 raised to power 5. The question now becomes, what do we multiply by itself 6 times to give us 64? So let us try 2. We know that 2 times 2 times 2 is 8. 2 times 2 times 2 is 8. 1, 2, 3, 4, 5, 6. 8 times 8 is 64. Very good. So the 6th root of 64 is 2. So this is 1 over 2 raised to power 5. And we know that 2 raised to power 5 is 2 multiplied into itself 5 times. That is 2 times 2 times 2 times 2 times 2. 8 times 2, 16 times 2, 32. So this is 1 over 32. Number 51. 2x raised to power half multiplied by 3x raised to power minus 5 over 6. Sorry, minus 5 over 2. And as usual, we deal with the coefficients 2 and 3. 2 times 3 is 6. We have x raised to power half. Because of the multiplication, we add the indices. Half plus minus 5 over 2. Six x raised to power half plus minus is minus 5 over 2. The two fractions have the same denominator, so there's no need to find the LCM. We simply deal with the numerators. This gives us 6x. 1 minus 5 is minus 4 over 2. 2 into itself, 1, 2 into 4, 2. So we have this as 6x raised to power minus 2, or 6 divided by x squared. Number 53. 16 over 9 raised to power minus 3 over 2. And as usual, we have a negative index. To remove the negative sign, we flip the fraction upside down. The denominator becomes the numerator and the numerator becomes the denominator. So this can be rewritten as 9 over 16 raised to power 3 over 2. And according to this, where 3 is equal to A, 2 is equal to B, and x is equal to 9 over 16, we can write this as square root of 9 over 16 raised to power 3. This is equal to square root of 9 is 3, square root of 16 is 4, because 3 times 3 is 9 and 4 times 4 is 16. This raised to power 3. 3 raised to power 3 is 3 times 3, 9 times 3, 27. 4 raised to power 3 is 4 times 4, 16 times 4, 64. Number 55. 4 a cubed b multiplied by 3a b raised to power minus 2. As usual, we deal with the coefficients 4 and 3. 4 times 3 is 12. A is raised to power 3 multiplied by, we add the indices. Here, A is raised to power 1. B here is raised to power 1 plus minus 2. So this is 12a, 3 plus 1 is 4, b, 1 minus 2 is minus 1. So this is 12a raised to power 4 divided by b. Number 57. We have the square root of 125 raised to power minus 1 over 3. We start with simplifying everything under the square root sign. And according to the very last law, we have that this is equal to the square root of 125 raised to power 2 times minus 1 over 3. And we know that this is 125 raised to power minus 2 over 3. Then we come to this. Here we have that x is everything under the square root sign. X is everything under the square root sign, and a is equal to 2, because this is square root. A is equal to 2. We can do this, but by convention we don't. So we have that x is everything under the square root sign and a is equal to 2. So expressing this, which has been written as this in this form, we have 125 raised to power minus 3 over 3 raised to power 1 over a is 2, 1 over 2. And once more, going back to the very last law, we have that this is 125 raised to power minus 2 over 3 multiplied by half. 2 will go into 2, leaving us with 125 raised to power minus 1 over 3. And we, of course, know that we can express this to remove the negative 1 over 125 raised to power 1 over 3. And according to this is the same as 1 over cube root of 125. And once more, the question becomes, what do we multiply by itself 3 times to give us 125? And we know that that is simply 1 over 5. Number 59. 2x raised to power half multiplied by 2x cube raised to power 3 over 2. First of all, we expand. So this is equal to 2 raised to power half x raised to power half multiplied by 2 raised to power 3 over 2 x raised to power 3 times 3 over 2. We remember this last law. 3 times this. So further simplifying, we have 2 raised to power half x raised to power half times 2 raised to power 3 over 2 x raised to power 3 times 3 is 9 over 2. Now, we have 2 here, we have 2 here. 2 raised to power half multiplied by 2 raised to power 3 over 2. According to the first law, we have 2 half multiplication. We add the indices plus 3 over 2. And we have x raised to power half here. Multiplication, we add the indices plus 9 over 2. So what do we have? We have 2. And as usual, the two fractions have the same denominator. So we simply go on to adding the numerators. 1 plus 3 is 4 over 2. X, the same thing goes here. 1 plus 9 is 10 over 2. And this simply gives us 4, 2 into 2, 1 into 4, 2. This gives us 2 squared x, 2 into 2, 1 into 10, 5. X raised to power 5. Of course, 2 raised to power 2 is equal to 4x. And that's the answer. So with that, we come to the end of exercise 1D and today's video. Thanks for joining, and see you in the next one.